All right, so welcome to our session, Simplifying Data Access from OpenEdge with Autonomous REST Connector. And I was told during the dry run for this presentation that I needed to start with a story. So let's start with a story. Once upon a time, if you wanted to get a hold of me, and this is sort of dating myself, but back when I was younger, when I was a kid, if you wanted to get a hold of me, you had really two options. You could call me on an old rotary phone or perhaps a cordless phone, or you could send me a note, a letter in the mail. And that was just the world that we lived in. And you flash forward to today, and instead, if you want to get a hold of me, any of these options over here on the far left will work. And this isn't just like possible ways to connect with me. This is the actual ways that people connect with me on a pretty regular basis. So I don't know why I need to be that much in touch, but apparently I am. And if somebody calls me, I rarely answer, and I don't remember the last time I got an actual honest to God letter. So what we're going to talk about today is connectivity, and we're going to talk about the way things used to be from a connectivity standpoint and the databases and the data sources that we used to connect to. And we're going to contrast that in the same way with all the myriad of ways that we are connectable, or the data sources and the databases and the applications that we can connect to today. And so what we're going to do is we're going to talk about this new product that we've got called Autonomous REST Connector, and it's new from the Data Connectivity and Integration Group, the DataDirect group over at Progress. So we're going to talk a little bit about that. My name is James Goodfellow. I'm in product marketing for DataDirect. I'm joined by Ken Butler. Ken is in product management for DataDirect. I'll go through some slides, talk a little bit about who we are and what we do, and from a connectivity standpoint, I want to talk a little bit about where we came from in more depth, trends that we've seen in this space, and then as we lay out the groundwork for why we did this, why we made this change, why we made this shift. And then from there, let's talk a little bit about how Autonomous REST Connector allows you as an OpenEdge user or as really any application developer, database user, how you can leverage Autonomous REST Connector to connect really any application to any database. So data access has changed a lot over the past few decades. We went from connecting one machine to another. We went from most of our connections being between on-site data sources and on-site applications, so we didn't have to worry about cloud applications or software service applications, and we didn't have to worry about remote cloud-based storage and off-site applications or off-site data stores, and that was great. But as the world changed and as our network expanded, we've got a significant, higher number now of these available data sources and applications. But in addition, we've also got, these new applications are out of our control, and we lose sort of that security layer. So app developers have traditionally had this very limited controllable sphere. Now we're moving into a realm where there is less control and less ability to be able to control what happens on those networks and with those data sources. This should look familiar. This is really, the traditional SQL approach. You've got your OpenEdge application and your data source. You've got a JDBC, ODBC connection that runs you directly to the data storage sources or the other applications that you need to connect to. And this has worked for a very long time. But as we know, as we move forward, data sources and availability of data access has changed, and so we need to change along with it. And so this begs the question, why don't we use ODBC or JDBC to connect with these new data sources? And that makes sense theoretically. It's just that we've come to expect so much out of our application and out of our data sources, and we really degrade quality of service, and we really open up and expose a lot more application Achilles heels when we do that, when we open up. So as a result, what we look to do instead is how do we how do we address these challenges? There are several roadblocks really that pop up when you're talking about open application data and the customers who need to get to that data. First, most of the BI and ETL tools that you're using, they don't necessarily support OpenEdge right out of the box today. Second, most of the tools do support ODBC and JDBC, as these are the most popular data access standards. And then third, while these open standards are plug and play for the most part, they lack the data security and integrity layer that becomes more and more important today. And so what this has led to is what I call the rise of REST APIs. So one very popular way of addressing the data integrity concerns is by locking down these data sources and exposing the data really as an API. And recently, we've all seen how API access has superseded the access, whether it's ETL and moving data around. Instead, enterprises are preferring instead to take the quicker route and the more secure route of exposing data via an API and then allowing users to access it and be able to control who can access it, which data they can access, how they use it, and that additional control really comes into play when you're using the API. The graph down in the bottom I think is great because it shows just, this is from Programmable Web, and what this shows is, a massive shift, a massive explosion in the world of public and private APIs. 20,000 public APIs and, over 100,000 private APIs, and that number just continues to grow. So to confront or to address the API market, we launched Autonomous REST Connector, and this is an intelligent, customizable data connectivity solution. It enables lightning-fast, codeless connections between your OpenEdge application and the data that your customers and that your users need to access, and they need to access it through their preferred BI or analytics tool. And there's really four primary characteristics. One is that SQL access. So you've got the API, but you still need SQL access so that you can run your queries the way that you've always run them. Two is the ability to normalize the JSON results and the returns. Three is intelligent sampling. This is really our secret sauce. This is not only do we offer this lightning fast connection, but we also, the system is able to intelligently look at the metadata of your results and be able to pre-build the schema so that you can go right to analyzing data. And if you need to change that, you can, but it's already set up as sort of a baseline once you first access it. And then four, authentication. So now you can control really which data the users have access to. And so when you drop Autonomous REST Connector into the mix, this is what it looks like from a schema standpoint. Enterprises are modernizing how they allow customers, both internal and external, to access this kind of data. And so this new approach is really to expose data as a service as opposed to allowing applications or user to go directly to the source. And again, degrading that quality of service and the security measures that we become really beholden to. So this is really being done to standardize how data is accessed from a governance perspective, but it also allows for a standard way to consume data across all your users, internal and external. And Autonomous REST Connector really allows the correlation, or the conversion rather, between SQL and REST. So think of it as a translation layer, right? It converts API data into a standard, a SQL standard that SQL applications can run without having to natively access that API. And so there are several benefits to this new Autonomous REST Connector approach. First, and this really can't be overstated, you can connect your API to any ODBC or JDBC tool. So this is a very powerful statement. This opens up a vast world of possibilities when you're talking about the data that you need your applications to connect to and the applications that you need to consume your data. Second, zero code. It's a no-code solution. If you saw Dion give his presentation earlier this morning, you grab the URL for the API, you drop it in, you click a couple of buttons, and then you have access to the data in a tabular format, and you can do with it what you need to in Tableau or Power BI or whatever the application is. And then finally, building the seamless connectivity is essential to real-time data analysis. Autonomous REST connector is not only fast and an easy API connector, but it also empowers us to query API data as seamlessly as if it was native, as if it was in our native application. And so with that, it's easy to talk about, but I want to turn it over to Ken so he can actually show you what it looks like in action.
All right, how's that volume? Pretty good in the back, Aaron? All right. So just by a quick show of hands, I'd like to just kind of get an understanding of the audience here today, given the name OpenEdge in the topic title. Any OpenEdge customers? Okay, so almost everybody, except for in the back there. That's DJ, I see, right? Okay, so this is a fully OpenEdge room. So quick word of warning, I am not an OpenEdge expert. I'm an expert in data connectivity and integration. So if I get any small little details wrong, I apologize in advance. But I just want to, James gave you a pretty good high-level overview of what we were trying to do with the autonomous REST connector. And just very simple, basic breakdown is, if you're going through any type of modernization effort where you're trying to expose APIs on top of your OpenEdge installation, and you need to provide, you want to provide your customers a analytics tool of choice or a BI tool of choice. What are they going to use? So the autonomous REST connector is that bridge between SQL tools and OpenEdge, or really any other source that's being exposed by a REST API. And so I'll show you how quick and easy it is to work. So something within OpenEdge is called the Data Services Catalog. And that is right here. It may be a little bit difficult to see, but let me just send a quick response. And the Data Services Catalog essentially is a metadata document that describes all the different services that are available to you within that OpenEdge deployment. And so this is the standard sports service Data Services Catalog that has been used in demos across Progress probably for 10, 15 years, definitely longer than I've been here. I've only been here for about a year. But essentially, there's a bunch of different endpoints here. We have a customer's endpoint, and you can see all the metadata specific to that. So the great thing about this is that it's telling you the data type, the column name, the name of the REST point. So it very easily tells our connector exactly what we need to do when we're trying to convert that into API. So if we take a look at this, one of the more difficult things to do is when you are working with JSON data is your customers aren't necessarily used to working with data in that type of format. There's a couple different approaches that your customers or your partners may be able to do to work with JSON. Anybody in the room have an idea of what you would do if you had to work with JSON with a SQL tool? Convert it, maybe? Maybe you'd have to convert it into a CSV file. Maybe you'd have to find an SDK that allows you to run SQL through it. And a lot of these are mainly point solutions. You would have to do this for almost every single API out there. And so what we're able to do with the autonomous REST connector is give you a generic solution. You can connect to any API. It's not a point solution. There's not code you have to maintain. There's not a time investment that you have to use to build that. And so when you look at business analysts or anyone that's doing something with analytics or data integration, they're used to working with the data in rows and columns, right? And so we're using the autonomous REST connector here. I just did a simple select star from the sports service and the customer endpoint. So we essentially convert the endpoint into a table, and all that JSON data we convert into relational format. So that's part of the sampling and the normalization process. As we go through the hierarchical JSON data that gets returned from the endpoint, and we're able to normalize that into a relational data model. And so we're able to understand the data types, the column names, and extract also table names as well too. But this is a fairly simple endpoint. It mainly has customer data. But the great thing here is that if we want to take a look at leveraging any endpoints that are using ABL, maybe you have a lot of business logic that you don't necessarily want to rewrite when you're exposing these APIs, we can take a look at this data right here, and it returns customer data from Wisconsin. And if we take a look at the same SQL query, and this is actually using ABL to dynamically mask the data that gets returned from the API. And so there's really two ways to do it. So if you want to expose some of your internal data to your customers, you can leverage that business logic that's already been rewritten, expose it within the API, and now your customers have access to some of your internal data, but it's already been masked, so they can't identify any of that personally identifiable information. Yes. Exactly. Seems like magic, right? It's fast. It's fast, definitely. And so just from like a BI reporting standpoint, one of the biggest use cases that we see is that almost every single major third-party BI or analytics tool out in the market today, whether it's Tableau, Qlik, Power BI, they generate SQL. That SQL gets sent to somewhere, and then they visualize the results, right? And so if you want to take a look at a specific item number, this is just item number 54, the results get returned, it went right back to that API endpoint, return that data, we convert it into the relational format. You can see all the items that have been shipped that have an item ID of number 54. And so what we want to do here is take a look at the average discount of item number 54. Maybe we have already a couple of canned reports trying to show us the top discounts that our salespeople are providing to us or the top discounts that our customers are getting. And we see that the average discount right now is 15.89. It's a little hard to see. But the cool thing is that all these different tools, they can actually generate very complex SQL. Something that if you're trying to do by yourself, if you're just working with the REST API and you're converting these REST APIs into CSV files, or you had some point solution where you were using an SDK, how in the world would you do a join across multiple endpoints? And so we're actually doing a join right here. If you can read that, we're doing a join across the item table and the order lines table. And we're essentially selecting the item name, number, price, and the average discount. So if we did have a BI report, we can just do that quick join that actually hit two different endpoints. We aggregated all the data to sort the top average discount on top, and we see that fins, for some reason, our sales guys are giving out fins with an 18% discount. Maybe there's a higher margin on that item, and that's okay. But the thing is that we can take something as complicated as normalizing all this data from multiple different endpoints and performing a join. And if you look at this from like an operational perspective, if I'm going through this modernization effort of trying to convert, going from direct database access to putting this API layer on top of my data sources, I don't have to change any of my business logic. I use everything that's already been written for me, whether it's ABL or my canned BI reports. It just works like that. And so I want to take a look at a couple other scenarios here. This is just a USGS data source here. Quick little SQL call. It's a single API. If we take a look at the data that's being returned, fairly simple here. Well, this is mainly the general idea of a record. So if I took a look at some of this data, it's hard to see. I can't zoom on this. I apologize. But we can basically see we have a lot of string data, some maybe Unix time data, some doubles, and some integers. And so if you're trying to work with this data, you kind of have to do an analysis of what does the data mean? What's the context behind it? one of the things that we do is when we do the sampling exercises, we make our best guess as to what the data type is. And we're actually trying to find related elements within this. And so if we find nested and complex objects within the return JSON, we automatically understand that that should be a parent-child relationships. We will automatically insert and identify parent and foreign key relationships. So if you're leveraging the autonomous REST connector, there's really nothing manual you have to do when it comes to the data normalization process. It's kind of like a magic black box. We do all of that for you. We do have a way for you to customize the results if you really feel the need to do that. There may be instances where we guess that a zip code or a postcode, especially in the US, is an integer, but it really should be a string. But really what we're trying to do is provide you the best guess. Because when you're working with JSON data, essentially everything is a string, right? So we have some heuristics involved within the normalization and sampling process to provide what we think would be the best guess for some specific data types. And so I'm going to go here really quick and show you that this endpoint basically has a couple parameters. There's a start time query parameter, an end time, an offset, and a limit. So that automatically tells me that I have two parameters that are responsible for paging. We fully support paging. We can push down all those different parameters as well. So you're not limited to just the 2,000 records that I'm pulling back here. You could get multiple thousands of records because we do support paging. And I also have a start time and an end time parameter. So that means those are some type of filters. And so the great thing about the autonomous REST connector is that we can actually push down filter selection. So right now, the data that I'm bringing back is December 2018. That was a pretty hectic time in terms of earthquakes. I think that's when the big earthquakes were happening within Hawaii. But I want the latest earthquake data. So the only thing I really need to do is I need to add these two query parameters for March. So we're going from March 1st to March 31st. And it hits that same endpoint. And the only thing that we're doing is we're just basically dynamically changing the query parameters and the URL generation based upon the SQL syntax. So if you add a where clause or any other type of filter that we're able to push down, we're just able to dynamically generate a new URL, bring that data back, sample it, normalize it back into the relational format, and now you can see I'm pulling back March data. So it's really as simple as that. There's nothing you have to do in terms of driver configuration or anything else. You just use the tool that you're used to, which is SQL, and you add your where clause. So if you're already proficient with SQL, you would be able to use the autonomous REST connector. One thing I would like to show is how to set up a new connection. And so we kind of were flying a little bit high level of, showing the type of SQL that we support. We are fully SQL 92 select compliant. So if there's any type of SQL that is within the SQL 92 spec, we are able to support that just out of the box. So to create a new connection, I'm using a JDBC driver today. I just need to select ARC. What I'm doing right there is I'm basically pointing to a jar file. That's all really a driver is when it comes to the JDBC spec. And I need to supply a URL. That's a little bit hard to see, but the only thing that really matters is this. I'm just pointing to a SpaceX API. And the SpaceX API is a little bit more complex than what we saw with the USGS data. The USGS data didn't have any real hierarchical JSON data being returned. So when we sample and normalize that data, it essentially became one single table. And so if I just finish this, that happens when I switch connections sometimes. So we'll take a look at the SpaceX data source here. And you can see from a data schema point of view, we were able to automatically generate 8 different tables. And so if you took a look at the JSON data that got returned, it's a very complex and nested data source. We're going to just take a look at this launches API here. And this is going right against that. So you can see a lot of different complex objects that get nested further in. And so what we're able to do, and when you take a look at the JSON, there's no real parent-child key relationships. So when you're developing your APIs, you're not inserting these foreign key IDs in there so that you have some type of relationship with the parent object. And so what we do is we're able to take all of that JSON and convert it into these 7 different tables here. And that allows us to do some fairly complex SQL queries like this. And this kind of goes back to the previous, what if you have hundreds or maybe even thousands of different BI reports that are looking at operational measures within your business, and you don't want to rewrite those anymore. So if I had some SQL that was being generated that wanted to show me my customers that had the highest payload mass from a SpaceX point of view, all I need to do is create a new connection, which took me about 20 seconds. I just point to that API, and the SQL that gets generated by these different third-party tools can just be used seamlessly. So there's no real downtime other than talking to us and trying to understand what some of the other technical requirements are. In terms of authentication, I know there are some, looked over here, I know you've been taking a look at the Autonomous REST connector. In terms of authentication, we support none, basic, header-based, and token-based. And in a couple of weeks, I think we'll have a release that will support OAuth 2 as well. So in terms of connectivity and authentication, we support almost any type of authentication that we've seen in terms of mass use case support. Yelp is an interesting one. And everything that I've been doing so far, we've been taking a look at single endpoints. But in practice, if you're trying to, that got really dark. In practice, if you're doing this, you're not going to be pointing to a single endpoint. Generally, if you're going through any type of modernization effort, you're most likely going to some type of microservices architecture where you have many, many different endpoints that represent many different objects across the enterprise. From a configuration standpoint, the way you point the Autonomous REST connector to different data sources is you can either select a single endpoint within the connection URL, or you can create a configuration file. Now, from a customer experience point of view, this is probably the best way we thought that we could kind of get through this, is a JSON document, key value pairs. It has the name, you just provide a name to the endpoint, and the endpoint itself. And what the Autonomous REST connector will essentially do is it will go and sequentially sample, normalize, and output the results of all of these different endpoints. So as long as they share authentication and some other different settings that are a little bit more technical than what this talk deserves, we'll be able to officially get to all of these without a problem. So we'll take a look at what this means. I'm going to connect to this configuration here. And so right when I select that SQL query, it'll sample, normalize that data, and return all of this back to me. And the great thing is that last week, I've been a little bit behind on Game of Thrones, and I have a 4.5-year-old and a 2.5-year-old. And so I had some people coming over to my house, and I don't necessarily have all the time in the world to make food myself. So the great thing about this is that I was actually use this in a real world example, is that I wanted to look for restaurants that delivered to my house and that had over a 4.4 rating. Really? Today? Let's see if I can bring that over here. Might not work. But by default, it looked like I was bringing back lawyers that were within the Cary, North Carolina area. And so this is just another example of changing some of those default parameters. As I recently moved from La Crosse, Wisconsin, and I changed my categories to restaurant from lawyers and La Crosse, Wisconsin from Cary, North Carolina. And so as long as the query parameters are available to you, whether it's through the API documentation or any other means, we're able to push those down and filter the results on the server side, as opposed to having to do that on the client side. So that's also one of the reasons why it seems a lot faster than it is in practice. And so I just wanted to show a quick example within Tableau from like a BI reporting tool perspective. This is using the Yelp API, just what I was showing you within that SQL tool. But that SQL tool isn't necessarily the most exciting thing to look at, right? You just have rows and columns of data. Anybody can really do that. But from a practical perspective, so I have a geomap here that automatically loads review data using those multiple endpoints. And so it's doing a join across those multiple endpoints to pull both reviews, rating information, and address data on the fly. So I just changed it from healthcare to restaurants. I believe, I'm not from the Orlando area, but I believe we're probably around this area right here. It looks fairly correct to me. And so Tableau is actually able to automatically generate all of this different SQL. It's using the autonomous REST connector. And the way you actually use a REST connector here is exactly how I was using it within that SQL tool itself too. And so if you wanted to just get a quick idea as to the various restaurants or ratings here, you can just change this. So maybe we want to go back to Cary, North Carolina. It'll just automatically rerun that query, generates the map, and so you can see how easy this is to actually use within practice itself too. Super easy. One last thing I want to show you before we save a little bit of time for questions is what actually gets output from this is a file that can be either persisted in memory or you can persist it to disk. And this file is actually what can be modified to customize based upon whatever your business requirements are. And so you can see from this API, we got a bunch of time series data. These are the table names, and these are the column names. And those aren't necessarily how I want my users to actually use those column names. And so the only thing I really need to do is to change a column name. I just have this formatting here. Just angled brackets, new column name, or angled brackets, new table name. I can even change the data types as well too. So I can go from dates to integers to varchars. I can change table names from one.open to just open. So if you have a very I know some OpenEdge implementations can have some very obtuse column names just due to, whether it was a different minimum size number of bytes it needed to be, or it was, abbreviated. You would be actually able to take your API and make it a little bit more business user friendly and convert it into any type of data scheme or format that you want. So with that, James, I think you have a slide here?
I literally have 2 more slides. All right, are we good? Yep. All right. So just to kind of sum it all up, really, I like to think of autonomous REST connector as being a factory. And I think Ken did a fantastic job of demonstrating how it becomes that sort of, it builds that custom connection that you need. It builds it quick, it builds it efficiently, and it gets you working with the data and the applications that you need to get to. And so we really, even internally, we consider it this internal factory for creating really enterprise grade, business ready, real time connectivity. So if I leave you with 4 ideas that you walk out of here and you remember Ken's great demo and you remember these 4 things, I think that we'll have succeeded. 1, it's fast. It's really quick. He just did multiple examples. Dion, again, did a really great example this morning in the presentation. It's codeless, and it's not codeless because it's something that everybody in the organization needs to necessarily have access to and create connections. But it's codeless because you have limited resources when it comes to architects and when it comes to developers, and you don't need another time suck on your resources. What you need is something that can get up and running quickly and effortlessly. It's intelligent. We talked about that secret sauce that it can sample the data, it can infer what you're trying to get at, and it can build that model. And then Lastly, it's customizable. It's not one size fits all. Data connectivity is never going to be one size fits all. And so it allows you, it creates the connection, but it also allows you the flexibility and the customization options to be able to get in there and make the changes so that you can get to the data you need and use it the way that you need it, and the way that your customers need it. And with that, we are done, and let's answer some questions if you have any. It's based on authentication, right? So it's based on your permissions you have to for what data you have to view, and that's again another big reason why we're pushing people toward APIs. Is because they have that ability to be able to mask. If you're talking about GDPR compliance, right? You need to be able to mask PII in an instance so that Ken can't access it because who knows what he'll do with it, right? But so you can control that.
Yep.
Good deal. Thank you, everybody.